Welcome to log and formal report writing. Here are some easy ways and the step-by-step process you are supposed to go through in the writing and what is needed from the students. So let's delve into it. So the steps in the report writing is 1, abstract, 2, the introduction, 3, the theory, 4, diagram of setup, 5, methodology, 6, we have the graphs, errors, calculation, not excluding your tables, you can add that to 7, we have the results and discussion, 8, we have the precaution, 9, we have the conclusion, then lastly, the references. So we'll be going into them one by one, know what is needed, the things to do, the things you're not supposed to do to make the work easy and presentable as well. So firstly, about the abstract. The abstract is about your experiment, the work you did, what you are looking for, what the experiment is about. That's the abstract. So you give a summary of that. So the concept of the work, what you are looking for in the experiment, it should be stated in the abstract. Secondly, how the experiment was performed. So a summary of your method, it should be in your abstract. You summarize everything up, give us some information from your method that will make your abstract reading very easy to know about the work you've done. Then your results, the results you obtained from your experiment, it should be also in the abstract. And also you talk about your error, what resulted in your error, what were the error margins, if there are some standard values that you compared to your calculated values, what were they, and the significance of that error, if they are large, if they are minute, what is the significance as well. So that's the entirety of your abstract. The abstract should be brief and it should be understanding. And also there are no paragraphs in the abstract. The abstract should be very presentable. Your alignments to be justified to make your readings very clear. Now on to the next one is the introduction. So with this one, the introduction is excluded for first years because first years don't write introduction in large report, but it is written in formal report. So I will take my time to brief you about introduction for formal report for first years and second years, which they are needed to write for large report and formal report. So the introduction is about background study. So the assignment you are working on, some related background, some research being done on that work, you can include them in the introduction. Tell us about some background study of the experiment. Then some conceptual explanation relating to the lab work, some concepts which can explain further about the work you are doing. It should be part of the introduction. Then also relating your experiment to the concept and background you've given. So you relate your experiment that you are doing to the concept that you stated and the background study. You relate them together to know what you are doing. Then also in the introduction, you note that you are supposed to cite every information that you've taken from AIs, books, articles, websites. You're supposed to cite them to prevent plagiarism because they are not your words. Take them somewhere. So you're supposed to cite them to know where they were taken from. So note that citation is very, very important in the introduction. You cite your work and note that you are not copying and pasting. You note that you are not copying and pasting. You paraphrase and make the words yours. Note that. And also, you're supposed to note that the citation should be in the KNUST style. Yes, there's a style for KNUST that they use in their citations. So it is basically the name or names of the author then the year they published that book, journal, article, or any other information that you picked from the year they published that. You note that too. That's how the citation is done for your introduction. Yes, so that's all about the introduction. You're supposed to note the most important thing is the citation. Very, very important. So our next thing to talk about is the theory. So the theory of the work. The theory is the expressions, the equations relating to your work, the lab work that you are working on. That's about your theory. You talk about the expressions, the equations relating to the work. Talk about that. Talk about how your calculations will be done. Talk about how your calculations will be done. That is, the equations that will be used in your calculations, in your graphs, they're supposed to be included in your theory. You break down those equations. If they are linear, you compare them to the equation of a line to know out which variable in the equation will be going for y-axis, which variable will be going for x-axis. So all of these are supposed to be stated and brought out in the theory to make your work very easy. Note that. Very crucial point. You should be able to also figure out the slope from your theory. That's the equation you'll be using for the work. You are supposed to figure out that slope, the significance of the slope, what that slope means. After plotting out your graph, finding your slope in the calculation, what are you supposed to get after that calculation? The theory is supposed to tell us all that. So that's about the theory. It's supposed to be brief and concise, not plenty. So for lodge reports, those who write in lodge reports, note that as well. Now our next thing is diagram of setup. So the diagram of setup for first years, basically they're asked to draw in their lodge books or their report books. So you look up for the diagram in the manual, then you draw them in your lodge book, and note that the diagrams are supposed to be labeled very well. So you label them, tell us the apparatus, the names of the apparatus in the setup that you are using. And also note the diagram of setup is supposed to be titled, to give the title of the diagram below the diagram. It shouldn't be on top, as in table of values. For diagram of setup, the titling is down. So you are supposed to note that for diagram. So for the second years, you are supposed to crop out the diagram from your manual in them, and you paste them in your writing. So with the second years, when you crop out your diagram from the manual, you can use either Paint application or Photoshop to do the labeling, to help you with the labeling. Don't just present the raw figure you cropped out. Make sure the diagrams are labeled very well to know to tell us the apparatus in the setup. Now the next thing we will be talking about, which is very important, is the graph. So how you present your results, your findings graphically from the experiment you did. So with the tables of values and theory, the graph should be easily plotted. You know the values that you are plotting, the ones going on the y-axis, the ones going on the x-axis. They are supposed to be known. You know that. Secondly, before you even start your plotting, you check out your values on the table. If some values are, let's say, 3 decimal places, 4 decimal places, which will make your plotting very difficult on the graph, you can round them up. The values can be rounded up to, let's say, 2 decimal places to make your plotting very easy. You can be round up to 1 decimal places to make your plotting very easy. It's also crucial. And make sure the rounding up should be corresponding. They are supposed to run through all the values, not just some specific values, but if you're rounding up, they are supposed to be for all the values. And also choose reasonable scales for the graph. So with the graph, choosing of scales is very, very crucial. You're supposed to choose scales which allocating your point from the table will be very easy. You have to choose reasonable scales. So with the choosing of scales, you look at your point, the lower value and the higher value. Then you know the range at which your values lie, then you choose the scale from. And with the allocation of the scale on the axis on the graph sheet, it is not compulsory for you to start from 0 if your value on the table is not starting from 0. It is not compulsory. You can break out some of the points, let's say starting from 2, starting from 4, starting from 5, starting from 10, corresponding to how you choose your scale. It is not compulsory to start from 0. Then after plotting, choose reasonable points for the slope to minimize errors. So the slope is supposed to be chosen from the point you've plotted. So choosing your slope, it is advisable mostly that you can choose your last and first point from the slope. That will give you like minimum error, but choosing some small or in between values can maximize your error. So note that too. Your error is sometimes picked up from the kind of slope you pick from your graph. So you note that you're supposed to choose reasonable points for your slope. Now, with the scale choosing, let's look at these two tables that we have here. Now from table 1, we can see clearly that the values on the table are very, very easy to plot on a graph. Looking at the x column, which is distance, and the t column for time, the values can be easily plotted with a scale choosing. That's for table 1. But for table 2, we can see that the first column, which is for force F, is having some exponentials. Yes, they're having some exponentials in them, and that's a big challenge for students, which I have encountered before. Choosing scale for these kind of values sometimes very difficult. So I'll be taking you through how to go about this to make your plottings very easy and the calculations easy as well. So this is what we do. Looking at the sketched graph here, we can see that on the y-axis, we are having F, which is the axis title for force. Then the bracket for the unit of the axis. So with this one, going to the table, we notice that the first table or the first column is having exponential here. It is having exponentials here. So what we will do that will make the plotting easy is we will omit those exponential and add it to the unit of the axis. So we add the times 10 to the power 5 or minus 5, to the unit of the axis. Then we maintain the unit for the x-axis, which had no exponentials, because we can find the scale for those values. So after you done that, you then come to choosing your scales. So with the scale choosing, you pick the initials of the exponent. So 2.2, 2.6, 3.1, 3.7, 4.0. Use those values to choose your scale. Since you've omitted the exponentials, that's how you're supposed to go about it. You choose your scale from these values to plot your graph. So after choosing the scale, plotting your point out and getting your slope, now onto your slope calculation. This is how it will be done. Since you omitted the exponential from the graph plotting, in the slope calculation, you're supposed to bring the exponential back. So after you've chosen the point for the f-axis, which is the y-axis, and the change in values for the x, which is the x-axis, as shown here. You bring the exponential of the force axis back to your calculation to make your calculation complete, because you omitted that exponential from it. So you note that very well. You're supposed to bring it back in your slope calculation because you did not add it in your graph. Okay. So now our next thing we'll be talking about is your error analysis. So with works that had calculations and those without calculations, you are supposed to give out some error that you encountered in your work that you did. So there are two ways of going by your error calculations. Firstly is precision error. Then we have the standard deviation error. So the most commonly used one is the precision error, which is used when you have standard values for this is used when you have standard values for the work you are doing. So with the work you are doing, if there are standard values that you can compare your experimented values with, if there are standard values that you can compare your results or experimented values with, you use the precision error to find the error margins between your calculated value or the results and the standard value. So that will give you the precision error, and it is always in percentage, so you therefore multiply it by 100 to give you the percentage error of the work. And also we have standard deviation error. This deals with work that has a lot of tables or values being taken from the experiment. So if there are a lot of values that were taken, a lot of tables that were drawn, which led to your calculation in your results, you are advised to use the standard deviation error to correct or bring out all the errors that were found in your values taken. So that's how you go about your error calculation. Now your next thing is about your results and discussion. The most important thing, telling us about what you had from the lab work, how your results was obtained, what you observed during your lab work. They are all be included to the results and discussion. So finding out your final report, you tell us what the results was, then you tell us the observation, the things you observed in your values taken, and if those observations are relevant to your theory. If those observations are relevant to your theory, you tell us about that. Then also you tell us about the significance of the slope. It should be also included in the results and discussion. Now you compare your results to the standard values, if any. Tell us about the error difference between them. So you tell us about your error difference in the results and discussion. Now you tell us if your yielded results was obtained successfully, or you were not able to meet your target that you set for the lab. It's supposed to be emphasized in the results and discussion as well. Now you can also give out real world applications to your observation and results obtained. So you can give out some applications to the work you did in the discussion. You tell us some small application that could be related to the results that you obtained from the lab work. Now the next thing we talk about is conclusion. So the conclusion is about summarizing your work, your results, your findings, summarizing out everything that you've done in the work. Then it will be stated in the conclusion. You explain the significance of the results briefly since you're concluding. You give some future suggestions about the work. Then you state some potential sources of the error and some limitations the experiment that affected your results. They are all supposed to be stated in there. Then you give some recommendations on the work as well. Since it's a lab work, it's a research work, you give some recommendations for future research work and all that. You give some recommendations on the lab work. That's about your conclusion. Let's not forget about precaution. The precaution is also supposed to be stated. The precautions you took in your lab work, you state them, you tell us the precautions you took to make your work successful, to limit your errors, and all that are supposed to be stated in the precaution as well. Now, the last thing we talk about is referencing. So, referencing is citing out the journals you took your information from, citing out the books, the website, giving out the detailed reference of the citations. That's your referencing. So, the citation you did in your introduction, you give out your detailed referencing to that citation in your references here. And there's a format that those references are supposed to be stated, which is the name of the author, you have the year, the title of the book, journal, or any site you took your information from, some specific topic that the information was picked out from. Then if the journal or the book has some specific volume, it's supposed to be stated. Let's say volume 3, volume 2, you're supposed to state that as well. And the page you picked the information from, you're supposed to add that page to it as well. Sometimes some references are backed with some website links. Some references are backed up with some website links. You can also add that to your referencing to make reaching out very easy. Now, note that your information must be from latest sources. So, picking out information from journals, from books, you're supposed to pick out the ones that are updated to latest news, the updates that the research group they've done to update out on information. You pick out your information from those sources to make you not misinformed about the work you are doing. So this is about the entirety of the report writing. So we have your steps, which is the abstract, the introduction, which we've talked about, the theory, the diagram of setup, methodology. Then we have your graphs, your error calculation, your results and discussion. We have your precaution. We have your conclusion. Then we have your references. So these are the steps you're supposed to go by to write your report, either large or formal. But for first years, the large report writing, we excluded the introduction, the theory, the method, and the referencing. So the theory, the introduction, the method, and the referencing is excluded from the first year lab report, large report, since their time frame is very short in the writing the report. Those steps are being taken out. But for formal reports, all of these steps will be needed for formal report. So note that formal report, you are supposed to have your introduction, your theory, your abstract, your diagram of setup, methodology, your graph, error, calculations, results and discussion, your precaution, your conclusion, your references. You are supposed to add all of these steps to make up a full formal report for your work. So these are the steps and the easy ways to go by in your report writing. Thank you and have a good day.